you say people prefer the Supermesh more over than the Supernode?
What is it?
Would you say people prefer Supermesh over doing Supernode?
Well, it depends what you have. Like anytime you have a current source, like this one, there goes one equation with Supermesh. With nodes, anytime you have a voltage source, you know what the node here, you know what the voltage at that node, I mean, that's 7 volts, right? So you lost an equation. That's what's nice about the Supermesh and Supernode. You actually can find the equation quickly or eliminate one of the equations. So mesh analysis is assign current in any direction. We always tend to assign them clockwise. This is I sub 1, I sub 2, and I sub 3. That means I should have 3 equations by 3 unknowns. And mesh analysis says find a closed loop, add all the voltages in a closed loop, it should be 0. Well, here's my big problem. That current source. So if I go to add the voltages this direction, what is the voltage across that current source? Nobody knows. Not you, not me. So I can't use this loop. I can't use this loop either because I don't know what the voltage right there. So that limits what I can do. Here's a loop on the outside. Let me get some markers here and highlight what I'm talking about, where the loop is. Highlight, there's a blue highlighter. What else? There's a yellow highlighter. Let's see if you can see it. There's an orange one. So I can travel this way. Can you see it? Does it show up on the screen? The yellow? I can travel this way. On the outside. So if I travel in that direction, I'm going clockwise. That's -7. Oh, down here, what's the voltage drop here? It's going to mark this plus to minus because I'm traveling this way, right? It's going to make it what? Plus 2 times I sub 2. Keep coming down. This current's going to mark it plus to minus 1 times I sub 3. Should equal to what? 0. There is no I sub 1, so I'll make that 0 I sub 1 because I'm going to be using my calculator here, bless you. Plus 2 I sub 2 plus I sub 3 is equal to 7. That is my first equation. Now I need another loop, another mesh. As I said, I can't use this one because of the current source. I can't use this one. I already used the outsides. The only one I can use is which one? The I sub 2 one. So there's another one. Let's highlight it. I can travel this way. So let's do a KVL for that loop there. Plus to minus, that's 2 I sub 2. I'm going to the right, I'm traveling this way clockwise. It's going to mark that resistor plus to minus. I need to know what is the current pushing from right to left through that resistor. What's the current going this way? So 3 times the current. What's the current that way? Try again. What is it? I sub 2 is pushing in that direction. Is there anything opposing to that?
Oh, I said 3.
Yep, I sub 2 minus I sub 3, right?
Oh,
The whole thing, yes. Keep traveling, plus to minus. I'm going upward. Notice I'm traveling this way. So plus 1 times, what's the current pushing upward?
I sub 2 minus I sub 1.
I sub 2 minus I sub 1. Clean that one. We have negative I sub 1. 3 and 2 and 1 is that 6 I sub 2. Minus 3 I sub 3 is equal to 0. That's equation number 2. So now I got 2 equations. I need one more. I got 3 unknowns. I better have 3 equations. Where is the third one going to come from? There is no other mesh that I can draw there, that I can write KVL to it. That's where the super mesh comes in. This current. The 7 amp is pushing down. What is the current down? When you look at all these currents, what is that current? What is the current down this resistor? Isn't that the 7 amps? But in terms of I sub 1, I sub 2, and I sub 3, what is that?
7 amps plus I sub 1.
What is it?
Is it 7 amps plus I sub 1?
Nope.
No, it's I sub 1 minus I sub 2.
2 times.
Nope. 2 is up there. Has nothing to do with it. Just looking at that.
No, 2 because the resistor. I don't know. I think it's
Isn't that 1 minus 3?
1 minus
yeah.
3, yeah.
1 is pushing down, 3 is pushing up. The difference between them is the current down. So I sub 1 minus I sub 3 is equal to 7. So to write that with 3 variables, that'll be I sub 1 plus 0 I sub 2 minus I sub 3 is equal to 7, and that is my third equation. So this current down is 1 minus 3. That's the nice thing about the super mesh and super node. You can find an equation quickly or eliminate one of the equations. Now I got 3 equations by 3 unknowns. I will cheat and I'll go to my friend here, Baba. And Baba's going to help me solve this equation. Simultaneous, 3 equations. I'm going to put the values for the first one, which is what? 0, 2, 1, 7. Second one, negative 1, 6, negative 3, 0. The last one, 1, 0, negative 1, and 7, right? Oh. Now we asked to solve it. And it says I sub 1 is 9, I sub 2 is 2.5, and I sub 3 is 2. 9, 2.5, and 2. So these are my currents. Now if you want to answer any other questions, I sub 1 is equal 9 amps. I sub 2 is equal to what? 2.5. And I sub 3 is equal to 2 amps. Let's see if that's really true. You get 9 amps coming this way, you get 2 up, the result is what? 7 down. If you take this plus this should equal to that, right? Or I sub 2 going in, and, well, it's not I sub 2, it's this minus this, so we can look and see what that current, so if you want to find whether that current go in this direction, isn't that I sub 2 minus I sub 3? 2 is what? 2.5, 3 is 2, that's a 0.5. Going this way. If you want the current going up there, up is what? 2 minus 1. 2.5 minus 9 is what? Is that 6.5? 2 point, what did I say? 2.5 minus 9, that's negative 6.5. That means what? It's really coming down of 6.5. So 6.5 coming down, 0.5 coming down, 7 out. So we can find everything about that circuit. We can find the voltage here, the voltage, the voltage, the voltage, the voltage. Everything you want to know, once we have these currents, we can find. Let's try another one.
Quick question.
Yes.
Equation 3 is I sub 1 plus 0, I sub 2.
Yes.
Why is I2 0?
Because there's no I sub 2 in it. The current through this I sub 2 is going outside of that. So it's I sub 1 minus I sub 3. But since I'm making 3 equations by 3 unknowns, I want to make sure when I tap them on my calculator, I don't mess up things. So anything that's missing, I put a 0 in it. Just like this equation did not have I sub 1, I put a 0 there. Let's take another one and put a source now, a dependent source in it. Again, super mesh. It looks just like the one we did, so let me look for something different. The back of the book, I'll try to find something different. Quickly there. Oh. Let's take this one. Determine Vx. Find Vx. And soon enough, you'll have to look at the circuit and say, okay, to yourself, because we're not going to give you a method to use. We're going to say, you decide. And soon enough, you'll be able to look at it and go, if I use nodal analysis, I'm going to have 3 equations by 3 unknowns. But if I use mesh analysis, I'll have 2, or vice versa. So you need to be able to look at it and say, okay, which method might be a better choice here? This is 8 amps here. This is 5 ohms, and Vx is defined plus to minus this way. I get 2 ohms here. I get 8. And this is 1 amp. And the question, find Vx. Again, anytime I see current sources, I get excited, go super mesh. Because there goes an equation. There's a current. There's a current. There's a current. 3 of them. That looks like 3 unknowns to me, but wait a minute. I already know one of the answers. This current's going this way, right? So what's the value of that current?
Probably
1 amp, yep. There goes one of the unknowns. There goes one equation. This current is the current going the outside of this. This current is the current going the outside of this coming in. This current is going this way, and here is going to split between these two. So this is 1 amp. 1 equation less. Let me call this I sub 1 then, and I sub 2. I have 2 equations. That means I need I have 2 unknowns. I need 2 equations. I need to figure a loop there to travel. I can't use this one. There's a current source. I don't know the voltage. I can't use this one because of that unknown. I can't use this one. That's unknown. I can't use this one. That's unknown. Unknown. There's only one loop I can use there, and that is this one, a closed loop. That's it. That's the only loop I can use. If I come back to this, that's a problem. If I come back to this, that's a problem. I don't know the voltage here, either one of them. There's only one loop, which means I'm only going to have one equation. I have two unknowns. I better think of another equation.
I1 minus I2 equals 8.
Okay, I like that one. We already know this current here, the 8 amp, is the current going which way? To the right, except you have them backward. The 8 is going to the right, so what is the current to the right? I sub 2 minus I sub 1. 2 is going this way, I sub 1 is going this way. So 2 minus 1. Since I'm going to write the I sub 1 first, so I'll go negative I sub 1 plus I sub 2 is equal to 8. That's equation 1. So I need another one. That's where this path comes in handy. I'm going to travel clockwise, so it's going to be negative 2Vx. And turn the minus. I'm traveling clockwise, going to mark it plus to minus. That would be what? Plus 2 times what? I sub 2. Let's continue. Oh, I'm entering the minus here. Minus what? Vx. Keep going. I'm coming to the left, plus to minus, because I'm traveling this way. This will be 8 times, what is the current going this direction? I sub 1. Keep going.
Minus 1.
Minus the 1. The problem with that is we get Vx. Because if you look at this, that's what? 8 I sub 1 plus 2 I sub 2 minus 3Vx equals what? 3. I can't solve it because it's 2 equations by 3 unknowns. So can we find what Vx is? Vx is what? Let's look at it. Vx is labeled plus to minus. They want the voltage plus on the top minus, and that means I need to find what the current down is. It's 5 times that current down. What is the current down now? 1 minus I sub 2. Very good. It's 1 pushing down, I sub 2 going up. The difference is coming down. So if I do that substitution back into this one now, I will have what? 8 I sub 1 plus 2 I sub 2 minus 3 times 5, 1 minus I sub 2. That's supposed to be an 8, isn't it? Equals 8. 8 times 1 is 8. So let's clean this. 8 I sub 1. That's a positive 15, and 2, that's 17 I sub 2. Trying to do them one step. This is minus 15. When you move it to this side, that becomes 15 plus 8, which is what? 23. So I cleaned that equation all in one step there, and that's equation 2. Now I'll go to my calculator here. Simultaneous equations, I got 2 of them. And the coefficient, what? Negative 1 1, and the answer is 8. The second one, 8, 17, and the answer is 23. Solve that. I sub 1 is equal to negative 4.52 amps, and I sub 2 is equal to what? 3.48 amps. Once you have these two, the question find Vx. Well, we know what Vx is. There's Vx. So what is Vx? Vx is going to be 5 times 1 minus I sub 2. What is I sub 2? 3.48. So what's 5 times 2.48 with the minus sign? Nope, I forgot to get out of this. 2.48 times 5.
3.48.
1 minus that.
Oh, right.
It's 2, right? So Vx equals 12.4 with a negative sign volts. Negative 12.4 volts. Okay. See if I can find one where you have to think which method might be better. Okay. Let's take this one. It looks ugly a little bit there. We'll take a look at it. I'll start from the top. And I have 2 amps going in. I have 4.7K. 3.1K here. $8.1K. I have 3.5K. 5.7K. A current source down of 1 and 1.7K here. We're not done with it. We have a 2.2K coming down. I want an ugly one. I think I found one. We have a current source pointing upward there of 3 amps. We got a resistor here of 6.2 K. All of that $7 volts. That's my circuit. Now, doesn't matter what I'm looking for, but if you, I'll wait till you finish drawing there. If I go back to nodal analysis, nodal, We know what the voltage here is. We know this is ground. We know the voltage here, which is what? 7? But I don't know what the voltage here. That's one node. 2, 3, 4, 5, 6, 7. I'm going to have 7 equations by 7 unknowns. Right? Every unknown node, if you know the voltage to it, that's an equation. I have 7 nodes, I don't know the voltage of them. This is 7 here, this is 0 here. This is unknown, 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 unknown. This one, and this one. If I do KCL here, mesh analysis, you can look, there's already 4 errors there. That means the worst is going to be what? 4. But there's one even good news for you. We know one of them already, the top one. What's the top one? 2 amps. There goes one equation. I'm down to 3 now. Now, I can't do a KVL or a mesh here because I don't know the voltage. I can't do one here. I don't know the voltage. I can't do one here. I don't know the voltage here. I can't do one this way. I don't know the voltage here or here. I can't do one this way. I don't know that voltage. It looks to me the only way I can really travel if I travel this way, there's no blockage along the way. I know the voltage of every one of them. So let me label these currents. I1, I2, I3. So if I go on the outside and follow that, let's travel this way. I'm entering the plus to minus. I'm going to mark that plus 7, right? Let's continue. I'm going to come this way. I'm traveling clockwise. Going to mark this plus to minus. What's the value of that? Plus to minus?
2.2.
So plus 2.2K times what's the current? I sub 3. Let's continue. I'm traveling clockwise. That's plus to minus. That's plus what? 3.5K times what's the current through it? I sub 2. Let's continue. That's plus to minus because I'm traveling this way. I'm going to the right. That's plus what? 3.1K times what's the current through that?
I sub 2 minus 2.
Yep, I sub 2 minus the 2 amp. Very good. Let's continue. We're going to go up, plus to minus. I need the current going up. 8.1K. And what's the current up there? I sub 1 pushing up and 2 amps down, right? I sub 1 minus the 2, not I sub 2, the 2. Is that 2 amp or 2 milliamp, that top one? I guess these are amps. Okay. Because it looks silly there. Because you're going to add 8.1, that's times 2, add 7 to that. You know? It's going to look like a tiny number, but that's okay. That's what they're given. That's what I have to look and see. Let's clean that. 7 plus 2,200 I sub 3 plus 3500 I sub 2 plus 3100 I sub 2 minus 6200, is it? Plus 8100 I sub 1 minus 16,200 equals 0. Where's I sub 1? I see one of them, right? So 8100 I sub 1, I sub 2, I see two of them, 31 and 35, what's that, 66? I sub 3, we get what, 2200? And let's add these numbers. I'll go to my calculator, it's too early to start thinking about them. 16,200 plus 6,200 minus the 7 when I move everything to the right side is 22,393. That's equation 1, EQ1. And that's the only mesh I can write. Well, obviously I got 3 unknowns. I need 2 more. Now we start looking at these current sources.
I sub 2 minus I sub 1.
I sub 2 minus I sub 1 equals the 1 amp, right? So I sub 2 minus I sub 1 equals 1. So let me clean that, just write them in order. Negative I sub 1 plus I sub 2 plus 0 I sub 3 equals to 1. That's another equation. EQ2. One more equation, then I'll jump on my calculator and solve it. This current is pointing upward. Upward is going to be what?
I sub 1 minus I sub 3.
I sub 1 minus I sub 3 equals 3. So clean it. I sub 1 plus 0 I sub 2 minus I sub 3 is equal to 3, and that's my third equation. Let's solve them. 3 equations by 3 unknowns. So the first one, minus 1 plus 1. I tapped it wrong. Minus 1, 1, 0, 1. The second one, 1, 0, negative 1, 3. That's this and this. The last one, 8100, 6600, 2200, 22,393. Solve. I sub 1 is equal to 1.325 amp. I sub 2 is equal to 2.325 amps. And I sub 3 is equal to negative 1.675 amp. Once I have them, any question you want to know, I can solve it. You want to know this voltage? 2.2K times I sub 3. The question was to find I sub 1, I sub 2, and I sub 3. but that's how you find them. So we love to see current sources there. Let's try this one. Four amps. Point one V1, I think. $96 volts. $40 ohms. 6 amp. V2. Now we have some more stuff here. 10 ohms right there. And I got 20 ohms right here. And V1 is this voltage plus to minus. The question says, if you were to solve this using mesh analysis or nodal analysis, can you tell me how many how many equations you're going to have for each one? Determine the total number of simultaneous equations that must be solved in order to find what V1 is. Using nodal, using mesh, and which method do you prefer? If you were to solve this to find what V1, they don't tell us what V2 is. So I keep looking to see, did I miss anything? Something has to be given about V2 here. Maybe they want in terms of V2, but that's it. In terms of V2. Let's give V2 a number. Let's say this is, I don't know. Pick a number. What do you want? 4. 4? How about 40? Just because this number is 96. Let's make it a big enough number. I want to find what V1. Which method do you think will be better? Well, let's think about nodal analysis. Going back to nodal, not mesh here. If you do nodal here, do we know what the voltage here is? Which is what? 96. Do we know what the voltage here is? 40. Do we know what the voltage here is? If this is ground, the bottom is ground. V1. Do we know what the voltage here is? No. It's 0.1 V1 higher than this end.
So 1.1.
1.1 V1. So it's V1 plus 0.1 V1, which is 1.1 V1. So how many unknowns do you see? One. One unknown. Which means one equation. That's all you need to solve it.
Kind of hard to beat that.
Well, let's see. That's true. If we do mesh analysis, there is what? I sub 1. There is what? I sub 2. We know that's 4 amps. We know that's what? 6 amps. How many unknowns? 2 unknowns. Which means what? 2 equations. So which method would you use here? Node analysis. And this is a super node, if you remember that. So with that method, you assign current in any direction that you wish. So maybe I'll call this I-20. I'll assign this I-10. And KCL of the super node. What is going to that super node? I got the 4 going in, plus I-20. And what's leaving that node?
6
I-10. 4 plus, what's I sub 20? That's the current going this way. It's 96 minus V1 over 20 equals 6 plus I sub 10, which is what? V1 minus 40 over 10. My LCD will be what? 20? 20 times 4, 80 plus 96 minus V1. 20 times 6 is what? 120? Plus 2V1 minus 80. It's only one unknown. 80 plus 96. Is that 176? 120 minus 80 is what? 3V1 equals 176 minus 40, which is what? 136? One 36 divided by 3, 45 and 1/3. Oh, 45 and 1/3. That's what V1 is. So you have to decide which method is the right one. Let's have you try one. I'll stop the camera and have you try one. And you decide which method you're going to use. Well, it says mesh, it gives you a little hint there. Maybe I'll take this one. I'll cover this one here. I want you to see what method they're recommending. So you decide. I'll freeze it. Oh, record, nope. Freeze.